Your AI-generated summaries sound convincing, but how do you verify they're actually grounded in the source material? You'll see how to build a fact-checking pipeline that automatically compares claims against reference text, then returns both a faithfulness score and the exact evidence that either supports or contradicts each statement. This isn't just about detection, it's about traceable reasoning.
Prediction. Reasoning equals, let's check the claims against the context. The text states Lee scored 3 goals for Colchester United, but the context clearly states he scored twice for the U's. This is a direct contradiction. Faithfulness equals false. Evidence equals goal count. Scored twice for the U's.
This demonstrates declarative program synthesis through DSPy's signature system, where the output structure is treated as a first-class constraint rather than an afterthought. The code shows how a check citation faithfulness signature enforces a strict response format, combining a boolean verdict, supporting evidence, and step-by-step reasoning, while leaving the how of generation to DSPy's optimization layer. What makes this distinctive is the dual role of signatures. They act as both a prompt template for the LM and a runtime schema for the returned prediction object. The pattern operates by decoupling task specification from execution strategy. The signature defines what fields must exist, like faithfulness as a boolean or evidence as a dictionary of string lists, and their semantic meaning, while modules like chain of thought handle how to populate them, automatically generating reasoning traces before final answers. This separation allows the same signature to work across different LM backends or optimization techniques without modification, as the compiler adapts prompts to match the declared structure. Field descriptions and type hints serve as guardrails for the LM, reducing hallucinations by anchoring outputs to the input context. The key advantage here is reproducible, self-documenting LM interactions that avoid the brittleness of handwritten prompts. By formalizing the output contract up front, you eliminate ad hoc parsing of freeform text while gaining built-in validation and introspection. E.g., the reasoning field explains the faithfulness equals false verdict. This pattern excels in pipelines where LM outputs feed into downstream systems, like fact-checking tools or retrieval-augmented generation, where structured, typed responses are critical. The trade-off is the initial design effort, but this cost is amortized across reuse, optimization, and maintenance. Let's break it down line by line.
Prediction.
Creates a prediction object to encapsulate the model's verification result. This structured output combines the logical reasoning process, a binary faithfulness assessment, and the specific textual evidence used, providing a complete audit trail for the claim evaluation.
Reasoning equals, let's check the claims against the context. The text states Lee scored 3 goals for Colchester United, but the context clearly states he scored twice for the U's. This is a direct contradiction.
This provides a human-readable justification for the faithfulness equals false verdict by directly comparing the claim 3 goals against the evidence scored twice, making the contradiction explicit. The reasoning field creates an audit trail that explains why the prediction was flagged as unfaithful.
Faithfulness equals false.
This Boolean flag indicates the prediction contradicts the source context. By setting faithfulness equals false, the system explicitly marks this evaluation as unreliable due to the verified discrepancy between the claimed 3 goals and the actual scored twice evidence.
Evidence equals goal count. Scored twice for the U's.
This provides concrete evidence to justify the faithfulness equals false assessment. The dictionary maps the disputed claim type, goal count, to the exact contradictory phrase from the context, creating a verifiable reference for why the original statement was incorrect. Faithfulness validation pattern. The check citation faithfulness signature demonstrates DSPy's ability to verify claims against source material by returning both a boolean assessment and concrete evidence from the context. Field descriptions in signatures clarify expected input-output behavior without requiring manual prompt engineering. Structured validation outputs like this enable automated fact-checking pipelines where both the verdict and supporting evidence are machine-readable.
The field that refuses to be filled already overflows.